All right, so this is number 42 on page 919. And this is a review of what we did, and that was section 12.4. All right, so this is what you have. You have these two polynomials. And this one, the first one, it says 5y squared minus 3y minus 1. And then you have this. 2y squared plus y plus 1. All right, so what are you doing to those two polynomials here? You're subtracting, okay? Now, adding is easy, but since we're subtracting, what is it you need to do?
Change the sign.
Okay, so when adding polynomials, the next step you really need to do is this polynomial here, I can remove the parentheses, correct? All right, and you didn't have to do that, but you do need to be careful with that subtraction. So it is a good idea to do that. All right, now remember this right here, remember you're subtracting, right? And so we also talked about the idea of changing a subtraction to addition problem. And when you change the addition problem, you add the opposite. So the 2y squared becomes a what? Negative 2y squared. Positive y becomes a negative y, and a positive 1 becomes a negative 1. Okay? All right, so that's where we're at. Now, what's the next step? So you got rid of the parentheses. What's the next step? Combine like terms. Very good. And notice that you only have one variable, correct? So since there's one variable, and I think one of the worksheets says to write it in descending order. So in descending order, that means you go from largest exponent to smallest. So which term, or what's the largest exponent that you see? 2. All right, so we're going to look at this term here, 5y squared. Can I combine that with another term? Yeah, right here. Now, what is this term right here? Negative 2y squared. Very good. Not 2y squared, but a negative 2y squared. And remember, all you're doing is adding their coefficients. So what's a 5, and what's this coefficient here? Negative 2. What's a 5 and a negative 2? 3. So 5y squared and a negative 2y squared becomes a what? Very good. All right, now, the next variable, or the next exponent will be what exponent or what variable? Y or the exponent of 1. So you have this one, and I can combine it with this one. Y'all agree? So what's a negative 3y and a negative y? Now remember, there's no coefficient. If you don't actually see a number, this is really understood to be a negative what? Okay. So what's a negative 3y and a negative y? Negative 4y. And then the only thing left, what are these called right here? Constants. So what's a negative 1 and a negative 1? Negative 2. So there's your answer. That's what we talked about the last class period. Okay? And then if you look at, let's say, number 58. All right, 58, you have 3x minus 2 plus 6y. And then you're adding that polynomial to this polynomial, 7x minus 2 minus y. Okay, so this time you're adding them. So the adding polynomials is the easy part. And since I'm adding them, I can just go right ahead and combine that like terms. Now, there are more than one variable. You see there's an x and a y. So I'm not going to ask you to put this in descending order. Normally we tend to just put in descending order if there's just one variable that shows up. So you have two variables here. So it does not matter whether you put the x's first or the y's first, but we tend to always put the constant last. So let's start with the 3x. So I can combine 3x with what? 7x. So what's 3x plus 7x? 10x. And then let's go to the y next. So a positive 6y and a what? Negative y is a what? 5y. So that's plus 5y, correct? Now let's do the constant. A negative 2 and a negative 2 is a negative 4. Okay? All right. So that's what we talked about. Now, what I want to do is remind you about something you had in a previous course, and also we talked about earlier in the course. If I have this phrase, subtract 7 from, let's say 5. Subtract 7 from 5. What does that expression look like? If I told you to write it as an algebraic expression or as a numerical expression, what does that look like?
5 minus 7.
5 minus 7. Not 7 minus 5. 5 minus 7. So subtract 7 from 5 means 5 minus 7, which is, in this case, is a -2. All right, so that's going to help us with, this is going to be number 48. Okay, so number 48, you have this. All right, 48, you have subtract y from, and you have this, y squared minus 4y plus 1. So I need to give you a worksheet that has that phrase on it. I thought I did, but I don't think I did. But it was something, the word subtract was on one of your finals. Okay, so what are you going to write first? What polynomial are you going to write first?
4y minus
Y squared minus 4y plus 1. So you can put that first. So y squared minus 4y plus 1. And you're subtracting what polynomial?
y.
Now, that's just one term. So do I need to put that in parentheses? No. We're going to do one in a little while where we will. But no, we don't here. And so remember earlier in this case right here, number 42, I went ahead and I changed all these signs right here. So I got rid of the parentheses, right? There's nothing to get rid of here, correct? So I can just go ahead and say, all right, I'm going to combine like terms, just put in descending order. The only term that has an exponent 2 is this one. So what will I write? Y squared. All right, now let's combine the y's. A negative 4y and a what? Negative y is a negative 5y, and then the only thing left is what? A constant 1. Okay? All right. Let's look at 50. Subtract this polynomial and this polynomial. Oops, I'm sorry. That one, number 50 says add, excuse me. Add, this is add. Add negative 3x squared minus 5x plus 2 and this polynomial, x squared minus 6x, that's a 6, plus 9. Now here you're adding. Remember, addition is commutative. The order which you add does not matter, right? 3 plus 7 is the same as 7 plus 3. Subtraction is not commutative. That's why you have to be careful with the word subtract. But here you don't. So does it matter which polynomial I'll put first? No, does not matter. So I'm going to put the first one first. So you're going to say negative 3x squared minus 5x plus 2 plus the other polynomial, which is x squared minus 6x plus 9. All right. And since I'm adding them, I can just go directly to combining like terms. Now let's go ahead and put this one in descending order. Let's combine the x squareds. What's a negative 3x squared and a positive x squared? 1x squared. Negative 2x squared, y'all agree? Okay, the x's. What's a negative 5x and a negative 6x? Negative 11x, and then your constant. Always put your constant last. What's a positive 2 and a positive 9? Positive 11. All right, so that was number 50. All right, 52. Subtract. All right, this is after 52, so you're subtracting 5y squared plus 8y plus 2 from 7y squared plus 9y minus 8. Now, this time you're subtracting from. Which polynomial must you write first? The second one, the 7y squared. So remember, subtraction is not commutative, so the order does matter. So you have to put the second one first. So that's 7y squared plus 9y minus 8, and then you're subtracting this polynomial, leave it in parentheses now. 5y squared plus 8y plus 2. All right, so that's how you have to rewrite it. Now let's get rid of the parentheses since I am subtracting. Can I automatically get rid of the first set of parentheses? Yes. So that's 7y squared plus 9y minus 8. Now to get rid of that second set of parentheses, remember this is subtracting all these terms, correct? So you learned in the previous course that you can also write subtraction as adding the opposite. So that means that when I add the opposite of 5y squared becomes what? Negative 5y squared. 8y becomes negative 8y, and then 2 becomes negative 2. And it also goes back to the idea of the distributive property. If you think about this, this is really negative what right here? 1. So you can distribute a negative 1 through here. Negative 1 times 5y squared is what? Negative 5y squared. Negative 1 times 8y is negative 8y. Negative 1 times a positive 2 is a negative 2. So the distributive property also comes into play as well. Yes?
So it's only when it's in parentheses we change the sign negative to
If you're
positive?
subtracting.
Only subtracting, because we didn't do that one for the one with the y squared to the y fourth plus 1 on the previous one.
No, you only change the signs from the polynomial that follows the subtraction symbol.
Yeah, it did. It was minus y, so we didn't. We don't add y.
No, you're only subtracting. You only
Oh, okay,
it's just one term. You're just subtracting y.
Okay, that's what I was trying to make sure.
Yeah.
I was getting a little confused. Okay. Thank you for that.
Mhm. All right. And then combine like terms. What's a 7y squared and a negative 5y squared? 2y squared. What's a 9y and a negative 8y?
Y.
Okay. And then what's a negative 8 and a negative 2? Negative 10. All right, so there's your answer. Okay. All right, so any questions on that idea? So in my math lab, you're going to have the word subtract from. So just know how to deal with subtract from. Okay? All right, so I do need to give you a worksheet on this. So I'm going to give you a worksheet on this next class period. Okay, so that's going to take care of 12.4. So I'm going to assign 12.4 probably tomorrow. So now we're running out of time. So you normally in the past I'd extend things. We're running out of time in terms of extension. So you need to keep up with my math lab. Okay? Okay, so, and if you weren't here last class period, make sure you go to the videos that from the class, because there are a couple we did with fractions, so you saw how to deal with that. The decimal part's easy, just use your calculator. So just review those videos from the last class period for this section. And also, I gave the worksheet out, and I think it was just a part A. I don't remember how many parts of 12.4 there were. But whatever it was, just a part A?
Yeah.
Okay. So it was just a part A, so I need to give you a part B next class period. But it was just a part A. If you weren't here, you need to print it. Okay, now, we started talking about graphing, remember? All right, 10.2, and this is where we're going to continue talking about graphing linear equations. Okay, now remember, in one of the videos that you had to watch on your own, you were told what a linear equation looks like in terms of an equation. It looks like this. AX plus BY equals C. So you're going to notice that for the most part, it's not always true, but for the most part, you're going to have the two letters, an X and a Y. Okay, you have an x and a y. And that's what it looks like. And what makes it linear, because next semester you're going to have quadratic. But what makes this linear is that the exponents of both x and y are both what numbers? What number? A 1. They're both 1s. Next semester, you're going to have something that looks like this. And that's no longer linear. Why is that not linear? Because this exponent is 2. Next semester, this will be quadratic. So the graph looks different. That's a different looking graph. A linear equation is easier to graph than a quadratic. A linear equation, all you need are how many points? 2. But it's a good idea to use how many? 3, just in case you messed up with one of your points. Because all the points have to lie in the same line. They have to be collinear. But quadratic, you're going to need a lot more points because that shape is different. It's a shape of a parabola that looks like this. Okay, but that's going to be next semester. All right, so this is what a linear equation looked like. And so when you started this section, or when you start looking at this section of my math lab especially, they'll have something. If you look at number 2 on page 738, you're given this linear equation, x minus y equal 4. That's a y. So you're given this linear equation. Now it's linear because both the exponents of x and y are 1s. All right, now when we graph this, what does the shape look like? It's a line. It's a line. Either the line's gonna rise, or it will fall, like this. It could be horizontal line, or it could be a vertical line. It will be one of those. That's what a line would look like. Either it's gonna, the line will either rise, it will fall, it will either be horizontal or it will be vertical. And we'll look at all those types. Now and this was number 2. In number 2, they give you a t-table already. So here's a t-table they give you. We talked about the t-table. And when doing a t-table, what variable should be listed here? X. You have to put the x here. Don't put a y here. You got to put the x here because it's got to be ordered pair. Remember we talked about the word ordered pair? X, y. And then y goes here. And I can't see what, let's see. They use, all right, so they give you 0 here. And you got to find y. They give you 2 for y, and you got to find x. And they give you -1 for x, and you got to find y. All right? And when you look at the video from section 10.1, it's kind of the same thing. They give you a t-table, and you're missing some values that you got to find. Okay, so let's, and notice there are three ordered pairs here, 3 points that you're going to be graphing. That's a -1. Okay. So let's do each one individually. So let's start with the first one. So to find the y value, that means I go to my equation, and wherever I see what variable, x, I substitute what number? 0. Okay, so let's do the work here. So x is 0, so I get 0 minus y equal 4. Okay? And so what's 0 minus y the same as? Minus y, or -1y, right? Okay, now remember you got to get y by itself. So how do you get y by itself? Divide by -1, good. And so therefore, -1 divided by -1 is 1. Therefore, what's my y value? -4. Okay, -4. So then I can go to my coordinate plane, and I can plot the point. I can plot the point 0, -4. Now remember last class period we talked about plotting points, and in that video you have to watch for section 10.1, they do the same thing. So now you can't see this, but you can see yours. Maybe I can. So when plotting the point 0, -4, or when plotting any point, where do you start? At the origin. Okay. Now always do the x-coordinate first. So either you're going to go to the right, the left, or you stay. And then the y coordinate, either you go up, down, or stay. Okay, so my x coordinate is 0. So what does that tell me I've got to do with where I'm standing right now? I stay there. So I stay the origin, right? Now my y value is -4, so what does that tell me to do? Go down 4. So 1, 2, 3, 4. So there's, so I'm going to put a dot here. Now if the direction says label, label does not mean just put a dot. Label means to indicate what the x and y coordinates are. All right, so you're going to do something like this. You're going to say, all right, well, I'm about to label it. So this is 0 what? -4. All right. Now remember, when indicating an ordered pair, you got to use those parentheses. Now, don't confuse that with an interval. Remember we talked about interval notation before? From 0 to -4. That's not what that is. So you got to look at the context of what you're dealing with. Here I'm dealing with plotting points. So that's not an interval. That's a point, 0, -4. All right, so let's do the next one. So this time, I got to find out what x is when y is what? 2. So I'm going to do the work here. And so I get x minus y, what's y? 2 equal 4. And all you got to do is solve for x. So how to get x by itself? Add 2 to both sides. And so therefore, what's x? 6. So this is 6. So then I go and I plot the point 6, 2. Okay, so we talked about quadrants last time. This quadrant that I'm pointing to is called which quadrant? 1. This quadrant is called which quadrant? 3. So remember, you go counterclockwise. So 1, 2, 3, 4, right? Okay. In what quadrant is 6, 2 located? Quadrant 1. 6, 2 is located in quadrant 1. So you start at the origin. X is 6, positive 6. That means I go which way? 6 to the right. So I'm here, correct? Does that mean I put a dot here? No, because I still have to deal with the y coordinate. So my y coordinate is what? 2. So then I move up what? 2. So this is where I put the dot. So that's the point 6, 2. And I label it 6, 2. All right. Now, really all you need are 2 points. So, but I could have made a mistake somewhere with one of those points. So let's just do the next one. And hopefully they'll all lie in the same line. Now let's talk about something else we discussed. The point, the coordinate 0, -4, 6, 2, those are also called solutions to this equation. So remember the word solution? So that means, and the reason it's called a solution is because when I plug 0, -4 back into the equation, the left side equals the right side. It makes it a true statement. All right. Now, how many solutions does this equation have? We talked about that last class period. An infinite number. An infinite number. The equations you had on test 1, the equation you had on test 2, the equation you had on test 3, how many solutions did it have, each equation? 1. It only had 1 solution. These equations, and remember when you go back, it only had 1 variable to begin with. What variable was it normally? X. Here you have how many variables? 2, so there's an infinite number of solutions. We can't list them all. So that's why we do what? Graph them. That's why we talk about graphing. So we're graphing the solutions. That's what we're doing. We're graphing those solutions. So far, I've graphed how many solutions? 2. I'm about to graph a third one. So let's talk about the third solution. So let's do that here. So I've got to find y this time when x is what? -1. So I get -1 minus y equal 4. All right, now be careful. You can't see this, but let me go ahead and... All right, so -1 minus y equal 4. Okay, so it does not matter whether you bring the variable to the right or the left. You just tell me what you want to do. What do you want to do? You want to... You want to add 1? Okay. All right. That's fine. So if you add 1 to both sides, a -1 and a +1 is 0. What's left, though? -1y or negative y equal 5. Now, the reason I'm putting -1y is just to indicate that at some point you're going to have to divide by what? -1. Because right now I'm multiplying by -1. The opposite of multiplying by -1 is to divide by -1. So that's your next step. And so -1 divided by -1 is 1. 1 times y is y. So what's my y coordinate? -5. All right, and so then I plot that solution. -1, -5. And what quadrant is -1, -5? Quadrant 3. So one of the worksheets on 10.1 asked you about quadrants. So it's quadrant 3. So you start at the origin. X is -1, so I go which way? To the left 1. And then y is -5, so I go which way? Down 5. So this is the point right here. -1, -5. All right, and then use a straight edge. I don't have a straight edge, but maybe I do. Then use a straight edge. Like a license, or I mean, it's very small, the grid, so you can use your driver's license or something. And hopefully they all lie in the same line. Now remember, at this point, how many solutions did I plot? 3. What am I about to do? When I graph this, what is it I'm really graphing? No. What is it the solutions. I'm graphing the solutions. And how many are there? An infinite number. Don't forget the arrow. Some of you are forgetting the arrow, and you're going to lose a point and be very upset with me. You're going to call me all kinds of names as you leave this building. So this point right here that I'm pointing to, is that a solution? No. Why is that not a solution?
It's not a line.
It does not line the line. All right. So this is the graph of x minus y equal 4. Okay? All right. Now let's look at this one. So let's do let's do 16. All right, so there's going to be 16. Okay, 16, you have y equals 6x plus, y equals -2x plus 7. Now, the easiest ones to graph for students, the easier ones to graph is where the variable y is already by itself. That's an easier one to graph. So you see like this is already by itself? And so now you can use a t-table. You use a t-table. And for those of you that weren't here last class period, one of the things I told the others to do on what on that part of the worksheet was I need 3 numbers. One of them has to be what? 0. One has to be negative. One has to be positive. All right. Now, technically, you can make them all positive numbers. But I need for you to start using this as 0, because 0 is going to be important in the next section, and you're going to see why. But also want you to get used to dealing with negative numbers. All right, so let's start with 0. 0 is the easiest one to use. If x is 0, so that means I got to find the y value. So if x is 0, I go to my equation, and wherever I see the variable x, what do I plug in? So I get y equals -2 times 0 plus 7, correct? Mm-hmm. And then order of operations, so I multiply before I add. So what's -2 times 0? And what's 0 plus 7? So I plot the point 0, 7. All right. Now give me a positive integer. 2. All right. So I get y equals -2 times 2 plus 7, correct? So we see the variable x, what do you substitute? 2. What's -2 times 2? And what's -4 plus 7? 3. So then I'm going to plot the point 2, 3. Now give me a negative value for x. Okay, -2. Okay. Now, you don't do something like -10, and the reason is because when you go to your grid, it's not going to fit in here. So use some numbers that's going to fit within the grid that you're given. Is that clear? All right. So -2 is going to be a little off, but it's fine. We can estimate where it is. All right. So when x is -2, I get y equals -2 times x. What's x? And then plus 7. What's -2 times a -2? And what's 4 plus 7? 11. All right, so then you plot those 3 points. So let's do that. So this is going to be, on this grid, that's going to be number 16, and it's y equals -2x plus 7. Okay, so what's the first solution? Okay, now here's a question. In what quadrant or axis does 0, 7 lie?
The y-axis.
The y-axis. So it's not a quadrant, right? So if x or y is 0, then it doesn't lie in a quadrant, it lies on an axis. And 0, 7 lies on the y-axis. Because remember, we start at the origin. X is 0, so I stay at the origin. But y is 7, so I go where? Up 7. So there's the point, 0, 7. Okay, the next solution was 2, 3. So I start at the origin. I go which way? Right 2, and then what? Up 3. So there's the point, 2, 3. And then the next one is -2, 11. So I start at the origin. I go which way? Left 2, and then up 11. So I have to estimate. So let's say this is 11 right here. So -2, 11 is about here. And then you just use your straight edge. To graph this, and don't forget your arrows. And there's the graph. Okay? So using a t-table. Using a t-table. Now, you could also, there's another section which we hadn't gotten to. There's another section that talks about slope. We haven't talked about slope yet, but you can graph the lines using their slope. But in this section, they want you to use not slope, but what? T-table. 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 All right. Now, notice that this line is rising. This line is what? Falling. You're rising, falling. In another section, if a line rises, the slope is positive. If the line falls, the slope is negative. So we're going to talk about that in a future section. All right. Now, let's look at number 12. You have x, -x, plus y equal 6. Huh? Okay. -x plus y equals 6. Now guys, you see how the variables are on the same side? And it's always easiest for students to use a t-table if they get one of the variables by itself first. All right, now the variable to get by itself first in this case is y, because y, the coefficient is what? Positive 1. All right, so get that by itself. And so that means I want to bring this -x term to the other side. So to do that, what do I need to do? Add what? Add x to both sides. All right, and so x and -x is 0. So now I get y equals, and let's put the variable x first. So y equals what? X plus 6. And now use a t-table. So it's always best if you can get the variable y by itself. And that technique's going to be important because in the last section of this chapter, which is on your final, You have to write this in slope-intercept form. So we're going to talk about slope-intercept. And slope-intercept form is where you get the variable y by itself. So start practicing getting the variable y by itself. Now, y would be easier to get by itself here because its coefficient is a positive 1. All right, so any questions on how we got y by itself? Okay, now I'll use the t-table. What's the easiest number to use for x? 0. So if x is 0, I get y equals 0 plus 6, correct? So what does y equal? 6. So then I found a solution. So one of my solutions is 0, 6. One of the points on my line is 0, 6. Give me the positive number. 1. If x is 1, I get y equals 1 plus 6, which is 7. Give me a negative number for x. Negative 1. Then I get y equals negative 1 plus 6, which is 5. Okay. So then I plot that point, those 3 points. So I plot those 3 points. So 0, 6 is on the y-axis. So that's here. 1, 7. I go to the right 1 and up 7. So that's in quadrant 1. Negative 1, 5. I go to the left 1 and I go up 5. So that's in quadrant 2. And then I draw the line. And all those points are collinear, so they do lie in the same line, so I did not make an error. Don't forget to draw your arrow, though, your arrows on both ends. So basically what we just talked about, is that slope positive or negative?
Positive.
Positive. So in a future section, you're going to talk about slope, and you're going to say that slope is positive. Positive slope. Okay? All right, now let's look at this is going to be number 13. I'm sorry. Number 14. Number 14. Okay, now you have negative x plus 5y equal 5. Negative x plus 5y equal 5. Now listen carefully. So what? You see how the variables on the same side? If you go directly and do a t-table right now, you may end up with fractions as your points. So you don't want to use fractions. When plotting points, you want to tend to use integers. You can't what? Okay. So you see how y this time does not have a coefficient of 1? So I would not get y by itself here. But x has a coefficient of what? Negative 1. X has a coefficient of negative 1. So that means that if I brought x to the other side, I would get a positive 1x. Okay, so what? Just watch what I'm doing. So I'm going to add x to both sides. And so I get 5y equal x plus 5, correct? Now I'm going to get x by itself. How to get x by itself?
Subtract 5.
Subtract 5, and so I get x equal 5y minus 5. So that's what I'm going to use. So x equal 5y minus 5. Now that's going to make things a lot easier for me. But here's what you got to remember. When we did number 12, what letter was by itself? Y. So when I said give me a 0, give me a negative number, give me a y number, I substituted those numbers into what letter? X. All right? And the reason I did that into x was because what letter was by itself? Y. So y was written in terms of x. Here, what letter is by itself? X is written in terms of y. So when I do the t-table, and I say let's and I say use 0, this time you're going to put 0 in place of what? Y. You're going to put 0 in place of Y. That's why when you go back to the problem we did earlier, the first problem, they gave you a t-table, and they gave you a number for X and they gave you a number for Y, and you had to fool around to find the other one. And that's the reason. So you're not always going to substitute numbers into X. You could substitute numbers into what? Y, depending on what letters by itself. So just remember, you're trying to find X, so you got to give a value for Y. So if Y is 0, let's find out what X is. So X equal 5 times 0 minus 5. What's 5 times 0?
0.
And 0 minus 5 is A. Okay, but now that's the value of what letter, though? X. So now you plug the point, negative 5, 0. Now give me another value for Y. You want to use 4. 4 would be too big. Because look, and here's why. You can tell right away why you wouldn't use 4. Now, technically, if you had it an extended plane, you could. What's 5 times 4? 20. 20 minus 5 is what? 15. I don't have enough grid space here. You see it goes up to 10? Okay. So pick a different number instead of 4. 1. All right, so if Y is 1, I get X equal 5 times 1 minus 5. And what's 5 times 1? And what's 5 minus 5? 0. All right. So then I found another solution. Another solution is 0, 1. Now give me a negative number for Y. Negative 3 would be too big for me. Negative 2 would be too big also. Now here's why. I want you to think why. So what's 5 times negative 2? And what's a negative 10 and negative 5?
15.
Negative 15. You would be beyond this white space. So let's try and keep it within here. Negative 1. You only had one integer left to choose from. Okay, I'll put it in the wrong place. Okay, Y is negative 1. I have X equal 5 times negative 1 minus 5. What's 5 times negative 1? What's the negative 5 and negative 5? Okay, it'll fit. So negative 10, negative 1. All right, and so then I go and I plot those 3 points. Where does negative 5, 0, where's negative 5, 0 located? The x-axis. So that's here. Where is 0, 1 located?
Quadrant 1.
No.
No, it's on the y-axis.
The y-axis. 0, 1. 0, 1 right here. Okay. Negative 10, negative 1 is located where? Third quadrant. So negative 10, negative 1 is here, right? Remember, if the direction says label, you got to label these. Negative 10, negative 1, negative 5, 0, 0, 1. And then just use a straight edge. Use a straight edge. Something like this. And there's your line. Okay? All right. So we're gonna stop on this part and we're gonna look at something else. But before we do, and with. It's not a difficult section. Most students can handle this. This is number 2. And I want you to remember how to deal with this. This is number 2 on page 925. Huh? What? Oh, 12.5. So you have 6x times 3x squared. You've had this already. How are you going to multiply these two polynomials? Now notice, these are actually polynomials because a polynomial can be one term. So you have the 6x times a what? 3x squared. One term times one term. That's the polynomial is one term or more. How did you multiply this in the previous section, though? What do you do? What rule do you use? What's that rule called? The product rule. Product rule. Remember, product rule says when you multiply like Bases, you do with those exponents. Add them. So what's x times x squared? X cubed. And what's 6 times 3? So what's the answer? 18x cubed. Okay, number 12. You have x times 5x to the 4th times negative 6x to the 7th. So how many polynomials am I multiplying together? 3. Do the coefficients first. What's this coefficient right here? What's this coefficient? What's this coefficient? So when I multiply them, what do I get? All right, now use what rule? Product rule. What's x times x to the 4th times x to the 7th?
X to 12.
7, 8, 9, 10, 11, x to the 12th. Y'all agree? Because that's a 1, that's a 4, and that's a 7. You add them, you get 12. All right, so that was from a previous section. Okay, now let's look at this. 14. You have 2x times 6x plus 3. How are you going to multiply that? The distributive property. Very good. So remember that x wasn't there. You distributed 2 to get rid of the parentheses, correct? But there's an x there. So you can skip the step, and most students do. But in your mind, this is what you're saying. You're saying 2x times what? 6x. That's what you're saying in your mind. 2x times 6x. Then you're also saying plus 2x times what? 3. That's what you're saying. So that's a distributive property. Now you can skip that step, so you can go directly to the answer. What's 2x times 6x?
12x squared.
Yeah, and that's why we talked about this right here. So 2x times 6x is 12x squared. And then what's 2x times 3? And there's your answer. All right, so we're going to finish this. This is an easy section. We're going to finish this next class period, but I just wanted to remind you what we're going to do next class period. So 2 things you're going to finish up. The graphing lines, and then this part. Okay? All right. Now, make sure, I'm going to send you an email tomorrow as to what's due Thursday. But the videos that you have to watch, they're going to be due Tuesday, but I really would like for you to turn them in Thursday. Okay? But I'll send you an email as to what's actually due Thursday, tomorrow. All right, all of you sign the roll.